Okay, everybody, this is chapter 12, section 4. We're looking at angle measures and we're looking at chords inside of a circle. And then we're also looking for secants. Secants are a kind of a line that are outside of a circle. So this is a really dense section. There's just a ton of stuff in here, lots of different things. You got to know your vocab. And you're really going to have to keep a lot of these different formulas straight. There's a lot going on here, so you're really going to have to study and understand what you have in the problem. Okay, so we'll eventually deal with lines inside the circles and outside the circles together, and kind of have to identify what to do. So make sure you study and put stuff together. Okay. In this first theorem 12.13. Talking about two chords that are inside of a circle and they intersect. So they create an angle. They created angle 1. Okay. And I want to find that angle. When that angle intersects the circle and is actually creating an arc A to B and arc C to D. Now, if you guys remember, hopefully you do, that this angle 1 is vertical, and I could even call it, this is angle 1, 2. On this side, they should be equal. So those angles should be the same because they're vertical. That's a concept we've done a lot, especially really early in the year. And you're going to have to kind of remember it here on this one, okay? But if you take the theorem, the measure of angle 1 is going to equal half of the two arcs. So in this picture, AB and CD. If you take the sum of those two, and then, basically 1/2, you're dividing by 2. And that will get you the measure of the angle, okay? And of course, we can play games kind of with this formula too. Sometimes we could give you the angle and you got to find one of these arcs, okay? So just some games we'll play and some math we have to remember. We'll see how it goes, okay? Here we go. On the first example, they give you what they give you the two arcs. So really I just got to go angle 1 equals the one arc, so 122 plus the second arc, 90. And I write it this way: instead of multiplying by 1/2, I divide by 2. That's kind of what I do. So I'll let you do the math on that one. You want to hit pause for a second. Okay, so there you go. Angle 1 is going to equal 106 degrees. Okay. All right. So on this one, a little bit different. You got to be careful here because you're trying. The formula is actually getting you to find this angle because the arcs are intercepted here by that angle. But they want you to get this angle over here. Okay. Now just let's remember here, that's a line. We've been doing this all year long. That line's 180. So I want to go find this angle. Let's just call it X, and that should help me to get angle 1. So hopefully you follow that kind of thought process there, okay? So once you hit pause and give this one a shot, you really want to find angle X first, and then go ahead and do that. Okay, so I went ahead and found X. I'll make sure I get my notes a little bit better there. X is that, okay? So I end up getting 102.5. I think that's a radio station around here too. I don't listen to it, but I think it's a radio station. Anyways, but that's not the angle I needed. They wanted me to get this other angle that's on the other side, but I knew that they create a line which is 180 degrees. So I went down here and I subtracted it. and I believe that I get that angle 1 is 72.5 degrees. Or, I'm sorry, it's not so. My answer, I can't read my own writing. It's 77. It wasn't a 2, it was a 7. So 77.5 degrees. Okay. So that's a test question right there, making you kind of do some work to get something a little bit different than what the formula was getting you to do. Okay. Okay. Next one, theorem 12.14. If an exterior angle intersects a circle, then the measure of the angle is 1/2 of the difference of the two intercepted arcs. Oh my gosh. Well, let's break this down a little bit. Exterior angle just means that the angle is on the outside, okay? And it will intercept the circle in two places because there's two rays. Now, so it's intercepting the circle, let's say at that. It's created an arc, but it's also created another arc, okay? So this one out here. Okay, so we got to be careful on that. If we just kind of look at example B over here really quick, here's my exterior angle. It's intercepting the arc. The circle here is an arc, and it's intercepting another one here at the arc. Okay, so this could be a little bit different when we look at some of these things. Okay. So just be careful. You're getting two arcs. That's the biggest thing. There's I call it an inside arc. Like this would be, if I look at example B, this one right here would be the inside arc. If I could get my pen to work here, this would be the inside arc right here. This would be the outside arc. Okay, that's just kind of things I've come up with to remember how to set stuff up. Okay, so I'll keep saying that. All right. So let's go back to example number A, and let's kind of read the formula here too. I'm going to take X, angle X, and angle X is going to equal 1/2 the difference. Now you got to remember a little bit, this is a difference. That means I'm subtracting the two intercepted arcs. So I'm going to call like this one, I'll call it outside arc, so OA, and I'll call this the inside arc, IA. So it's going to be the outside arc minus the inside arc divided by 2. Okay, so that's how I'm going to kind of set mine up. That's what the theorem told me to do. It's just, you know, a lot of words and a lot of stuff going on. One thing you want to do is, you know, you're looking at this and go, what's the outside arc? Well, remember, the inside arc was from basically these 2 points created this 92, but the rest of the arc is the rest of the circle. And remember, a circle is 360 degrees. So that outside arc right there would be 360 minus 92, and that gets me, that's 268 degrees, okay? So that helped me get my outside arc. So 268 minus the inside arc, 92, and divided that by 2. Okay. So I'll let you guys go ahead and do the math on that, kind of figure it out from there. So if you do all your math correctly, and hopefully I did, angle X is going to be 88 degrees. Okay. All right. So this one, same kind of problem, just a little bit different. I do have an inside arc, and now I've got, they told me the outside arc, okay? But the angle's not encompassing the whole circle like in section A, so, or example A. So this one, I'm taking what they give me, but they gave me the angle. So remember, this formula up here was to find the angle. Well, now they gave it to me, but I still want to just take the formula. So let's kind of go back to this guy, and I'm going to use that again. But now I've got different pieces, okay? So the angle, 40 degrees, equals the outside arc which in this case they told us was 140, minus the inside arc. Well, they didn't give it to me. They did call it x over 2. Okay. So, you know, I like to get rid of the fractions, so I'm going to go ahead and multiply both sides by 2. Okay, and that just that gets rid of this for me, but it gets me 80 on this side equals 140 minus x. Okay, so you know, a couple of different ways you could solve from this point. I'll let you guys do that. Either way, we should get the same answer. So I subtracted 140 from both sides to get negative 60 equals negative x. X can't stay negative, so I multiply both sides by negative 1, and I get x is 60. Okay. All right, so there you go on those. Okay, example C is, I think, on the next page in your packet, and this one gets, you know, some math involved here. Let's just take it and set it up with, you know, how the formula was set up. I got an exterior angle. There should be a little angle symbol there. So my angle is really x over 2. It equals the outside arc. The outside arc is this guy. So x plus 70 minus the inside arc. So I'm going to put that in parentheses because it's a quantity and I'm subtracting it. And I'm going to divide that by 2. Okay. All right, so right off the bat here, I just want to get rid of the fractions. So luckily the denominators are the same. Go ahead and multiply, and they just get rid of it. And I get x equals, so I had x left on the top here. Now remember, if I'm minusing this quantity right here, I got to distribute the negative sign. So I get x plus 70 minus x minus 30, okay? So we got to kind of remember to do it all the way through. So if you guys will notice, the x's will cancel each other out because there's negative and positive, same value. And then 70 minus 30 gives me 40, okay? And if you went and took that 40 and plugged it back into the equation, you see that it comes out correct, okay? All right. So we come on down here to the ship one. Your picture's a little bit different. There's supposed to be a circle here. Okay, and let me redo this. Circle kind of intercepts the 2 lighthouses too. So let me do this. Pen work, please. Thank you. There's a really nice circle right there. So there's an angle here between the ship and the lighthouses. So you'll notice that it's intercepting this circle. There's a reef here. Reef is a bunch of rocks and some other dangerous things. And the lighthouse is trying to navigate you through that. So I've got an inside arc up here. I've got an outside arc over here, okay? They tell me that the arc between the 2 lighthouses is 120 degrees. They tell me that the angle of the ship to the lighthouses is 55 degrees. And they want to know what this angle right here, the arc angle, might be right here, okay? So they just want to know, hey, you know, will the ship be safe at the angle that it's at? We just need to see if it comes out to be equal, it's going to be okay. We're going to find out what that arc needs to be, okay? So I'm taking that theorem we had. I'm going to let you guys go ahead and set this one up and then do your work, and then let's just see if we got it. So if you want to hit pause, you're using the same formula you did before. Pretty much the same kind of problem we just did, so this should be pretty easy. Okay, so there's your map there. This inside arc would have to be 10 degrees for all of this to work out. So the ship it'll be safe to come into wherever it's coming into. You know, it's a navigational thing. They kind of, you know, they got GPS and stuff now, but kind of what old sailors used to have to do. Okay, not too many lighthouses actually work anymore. Kind of cool to go visit, but not too many actually are used for what they were in the old days. Okay, all right. Okay, next page. We have theorem 12.15. Okay, this deals with chords inside of circles and they're intersecting each other, but the chords are being intersected, and there's a ratio here between the lengths of each segment of a chord. So if you go to like the example in the picture, you have the segment EA. EA is part of this chord that's really AB, okay? And if I take it and multiply whatever that length is and multiply it to its other part, in this case EB, I can set it equal to the other chord that it's intercepting, okay? So that you're taking pieces of chords and multiplying them and getting them equal. It's a ratio thing too. You could set up a ratio on this and be able to do this too. But since we kind of got a kind of nice, easy little problem, we're just going to stick numbers in there and do that, okay? So let's take this first one, example A. I got this one segment X, and the other piece of it's 9, so I'm going to multiply it by 9, and that's going to be equal to the segments that make up the chord that it's intersecting. So that's going to be 6 times 3. Okay, so 9 times X is 9X, 6 times 3 is 18, and if I go and divide both sides by 9, I get X is 2. Okay, so there you go. All right, this next one, you know, we're being, like some people might call us being mean, but we're just trying to keep going with your math, your algebra skills. The hint here is to use the quadratic formula, because when you put this in, it doesn't really come out, okay? And there's not a bunch of room here, so at least on my page, there's not a whole lot of room. For you guys, I think that you should have enough room to be able to do this, but you know, quadratic formula takes up a lot of work. So I'm going to go to a separate page, blank page. I'm going to take, I'll just kind of redraw the circle over here. And okay, so if I take the theorem that they gave me, I could take, I'll start off with the x's. I could take the 3x, it's a segment of a chord, and I'm going to multiply it to its other part. I don't want to say half because it didn't cut it in half. And I'm going to set that equal to the other chord, its segment, so 2 times 4. Okay. All right, so this, I got to distribute here, so 3x times x is 3x squared, and 3x times -1 is -3x, and 2 times 4 is 8. So I'm looking at that, I go, well, how the heck am I supposed to solve that? Well, in algebra, what I'd want to do is get everything over to the left-hand side. So I'm going to subtract 8 to move it over here, and it's going to equal 0, okay? Now, if you guys remember a lot of our algebra review stuff, I'd want to try to X factor this, and I'm just going to tell you right now that you can't. And if I can't X factor it, then to be able to factor it, I have to use the quadratic formula. So if you guys remember this, it's that, okay? So this is going to be my A, that -3 is my B, and -8 is my C, and I want to go plug all that in, okay? So I want you to do this on your own. I gave you the formula, you got your values, plug it in. I do want you to get an answer, okay? But when you get down to the last step, remember it's plus or minus this. I only want you to add it because I am looking for a length of a line, and I can't have a negative value for that. So I only want you to add that when you get down here. And just another word of warning, when you do your math, whatever you get here, it should be positive for this to work. If it comes out negative, you probably made a math mistake. So go back and kind of fix that, okay? So if you want to hit pause, you can do that, and we'll put the solution on in a little bit. Okay, so remember, a lot of work here. So right here, I plugged everything in and did all my math. So when I get down to here, what I did was I took the square root of 102. It's not perfect. It's approximately 10.1. And remember, I said to add it because I have to get a positive number because it represents a length of a line segment. So I did that. It comes out to approximately 2.2. I rounded here, okay? Other math, we might want to have you go out a little bit further, but for what we're doing, this is okay. Okay, so that represents X. If I go back here and into your circle and I plug it back in here for 3X, I'm going to get, this is about 6.6. And then if I go plug it back in here, I'm going to get about 1.2. Okay, now remember, those are approximations, they're not exact. Okay, so taking a theorem that we had, not a really tough theorem, but going and throwing some algebra at you, making you kind of do that because you're going to need to do it later on in other classes. Okay, all right. Okay, so now we come down to a different kind of a similar formula, but a different kind of situation. Okay, these are called external secant segments. That's this piece right here and right here that's outside of the circle. It's part of a line that, the A, B, and C, D are chords, but they're part of this line that really originates from outside the circle. So these outside pieces are called secant segments, okay? And that's represented here in this formula, the two segments, using the same kind of formula we just did, but the outside pieces have to be used. And then EB here actually represents the whole thing. And ED here actually represents the whole thing. So you need the outside piece times the whole thing, equal to the outside piece times the whole thing. Okay, so hopefully we'll start off relatively easy. These kind of problems really lend into a lot of math that we have to be good at. Don't make mistakes. Okay, so taking the formula, and let's start off with this top secant. Okay, the outside piece is 9, but I have to multiply it to the whole thing. So the whole thing is really going to be 20. Hopefully that makes sense. Okay, equal to the outside segment of the other line. So the outside piece was 10 times the whole thing. Well, the whole thing is represented by 10 and X. And how do you put segments together? You add them. Okay, so a little bit of math there. You got to remember to put two segments together to make a bigger one. You have to add them. Okay, so if you want to hit pause, I think this math is really not that tough. We'll let you go ahead and do that, and then we'll put the solution up. Okay, so there you go. Sorry, I squished it here on the bottom of the screen. 90 and 20 is 180. I had to distribute here. So I get 100 and I get 10x. I subtracted 100 both sides, and then I divided both sides by 10, and I get that x is 8. Okay. Okay. Here we go. Next one. I'm going to set it up for you. This one's a little bit different, but I'm, use the formula. The formula tells me to do this, black and white, do it. The outside segment is x, but they give me the whole thing. It's 72. So remember, the formula says multiply it. Okay. The other secant, the outside segment is 40, but the whole thing is going to be 78. So I want to multiply those. Okay. So there you go. I'll set it up for you. I'll let you do some math. Hit pause. And we'll put the solution up. Okay, so get that, and I don't like getting numbers that repeat. That doesn't help me a whole bunch here, but I get 43.3, and I believe it's repeating. Okay, so there's that formula. So you really got to make sure that you're understanding that you got to multiply the pieces, but I'm taking the outside piece times the whole thing, and sometimes I got, like in example A, I got to go and do kind of some stuff like that. All right. Okay. Last theorem. This is kind of taking a bunch of stuff together that we've kind of already done. All right. So we've got a secant line. So that's this one on top. I've got an outside segment, and then I've got the chord inside. And now I've got a line that's tangent to the circle. If you remember, tangent means it's hitting it at exactly 1 point. Okay. So if you look at the formula here, I've got this secant segment, and I've got an outside part of it, and I've got the chord. And so what they're doing is they're taking exactly what we did in the last segment, or last theorem, sorry, and they're doing the same thing. But then they're taking the line that's tangent, and they're taking whatever it is, and they're squaring it. Okay, and I can set them equal to each other. All right, I don't want to read the theorem to you because it just gets crazy. Just remember, I'm using the same thing we just did, and I've got something that's a little bit different, so I'm doing something a little bit different to it. Okay. Unfortunately, some math here gets a little crazy. Sorry about that. We'll just kind of figure it out as we go. Okay. So we're going to take, in example A, we're going to take the outside segment and we're going to multiply it to the whole thing. So I've got to add those pieces together. Okay. So add them together as that. I'm then going to set it equal to, I'm assuming this line's tangent. Would have been nice if they told me that, but I'm going to assume that it is. So I'm going to take 5 and I'm going to square it. So over here, we're going to have to go ahead and distribute that, and I get 25 over here. Okay, so now I'm looking at that, go, what do I do with this? Well, it's some algebra here, and it looks like I'm going to have to get everything over to the left, so I'm going to subtract 25. Okay, and I look at that and I go, okay, I think I have to factor that, but I'm just going to tell you right now, you can't factor this. Okay, so if I can't factor it, I'm back to that quadratic formula again. So my A here is actually going to be a 1. Here's my B. There's my C. Okay, so I'm going to let you guys go ahead and do this one. I think you got plenty of room to do this. Once again, you are looking for a positive number because it's representing a segment. So make sure that when you get down to the end, you're only doing the plus part of that, plus minus. Okay, so if you want to hit pause, and then we'll look at the solution together. Okay, so there's plugging it in. I started over here. Okay, and then I had to come over here. All right, so eventually I get x is equal to approximately 3.4. So we did some rounding there also. Okay, all right, so let's go down to this one. This is kind of a bunch of problems mixed up into one. This would be a test question right here. Okay, so let's look at this one first. Okay, it's the same thing we just did. It's going to be kind of tough to do it because I got one variable y and one variable of x. Okay, but if we go back a theorem or two and just kind of look at the inside part of the circle first, let's find x, because I think that's going to be the easiest. If we remember, this is a chord and it's been broken now into segments because it got intersected by this chord. I can take each piece, so x and 12, multiply them together, and then I could set it equal to the other chord that's been kind of segmented. Okay, so I take its pieces. All right, so I think that's the easiest way to kind of get started here. I'm going to get 12x, and then over here I'm going to get 144, and I'm going to get x is 12. Okay, so that's going to help me a lot because this secant right here is associated with this tangent line. So now I'm going to go back and use the formula that we just did a little while ago. It's not going to be nasty like using the quadratic formula that we did. So I'm going to have you pause it and do it yourself and kind of see if you can get y. Okay. Okay. So I found that the outside segment was 2. Okay, and that's where that comes from. This 26 comes from these three pieces, so 2 and 12 and 12. So that's what gets me 26. And I get the tangent line as y, and I'm supposed to square it. So I squared it right there, okay? So 2 times 26 is 52. 52 equals y squared. I took the square root of both sides, and I got y is about 7.2, okay? So that wraps up section 4. A ton of stuff right there. Just really got to, really study this one, go back. There's a lot of things kind of going on. And, we threw some algebra at you. It made it sound like it's hard. These formulas aren't hard. And we just threw some math in to make it a little bit more difficult. But, there you go. Hopefully you did a good job, but really study this one. Okay? Thank you.